Okay, chapter 3.1. So basically, again, some review, but looking at how we can take a three-dimensional object and split it into its outside surfaces and make a two-dimensional shape called a net. So basically, back probably in junior high, you did some of this and you folded them up and made a shape like a cube or a rectangular prism. You may not have got into cylinders and pyramids like we'll do and spheres um, right now, but it's the same concepts basically. So it says, if we take a look at try these, it says trace the faces of a small box and draw its net. So kind of hard to do this on a video like this. You could um, take a box like a Kleenex box or something like that and just put it on a piece of paper and flip the sides and draw out the rectangles that are on it. What you'll find is if we do like a Kleenex box, if we do the base of it is usually the biggest, the top and the bottom. Okay, so if we trace around that and then flip it on its side, this won't be quite as big. Now this is freehand, so you can see that they should match up. And then if we flip it again, it would be back on its top. Okay, so then we flip it again, we're on the other side. So that kind of gets us all those longer ones, and then we flip it on its little side, and there's four of those, right? So, well, actually, sorry, I shouldn't say that. There's two of those sides. So probably easier to do, we'll just do one of them here. It's the same as the width. Okay, you could do it out long ways, but that's typically, it's not shown that way as often, so we'll keep it sort of the more common ways. So one like that, you could put this on the other side. You could attach it down here instead, but just one on each, right? Because, oops, there are, remember there's just 6 sides in a rectangular prism. Sorry, keep trying to, it's kind of more like that. Okay, so how many faces? It has 6. What is the total area of all the faces? So then you would have to measure, right? So let's say this is 20 centimeters by 10 centimeters and then 5 centimeters high, right? So the Kleenex box looks that we've done the net for looks something like this. There's the hole where the Kleenex comes out, right? So this is 20, this is 10, and this is 5. And so basically, just like the last question in the getting started, you would have 2 of, I'll call this A, right? So you'd have 2A plus, I'll call this B, 2B, and I'll call this C plus 2C. So you can calculate that on your own. I'm not going to worry about the actual calculations right now because we'll get into that in this unit. Okay, so first example here says, Maya built this wooden cabinet. She plans to use 2 coats of maple stain on the outside surfaces. This includes the bottom and the door. A 1-liter can of stain covers 80 square feet. Is 1 can enough to stain the cabinet? So that's what you'll find in this course is maybe you've done some calculating of surface area before, but now we're using it in an application. Okay, so what's nice here is they've given you the net. It looks really complicated because they put in sort of the equations and blanks where you can fill it in. So some measurements are done for you. Record the length and width of each rectangular face, then record the area of each face in square inches. Okay, so let me just scroll down so you can see the whole thing. So you can see here they've given this 16 by 24. So that's like the bottom here, 16 because this is 24, or 24 and this is 16, right? So these two are exactly the same. So that's 16 times 24. And then let's calculate what 16 times 24 is 384. Okay, then, so we've done the sort of top and bottom here. Then 48 times 24, that's like the door and the back. That's the biggest rectangle. So that here would be 48 times 24, and this would be 48 times 24. Looks very similar to our Kleenex box, it's just shown on its side. Okay, so 48 times 24, times 24, 1152, 1152. Okay, and then the left and right side here, 48 times 16. So kind of have to go on this side, 48 times 16, 48 times 16. There are the measurements along here. So you can see this would be 16. That's smaller than this one, which would be 48. And this would be 48 here. This would be 16. And this would be 16 as well. And this would be 24. So it's the same as that one. So now we filled in all the blanks. We just have to do 48 times 16. So 48 times 16 is 768. Okay, so we've got all of those. What is the total surface area? So basically, just like I did in the try these, 2 of everything. So 2 of 768, 2 of 1152, and 2 of 384. So you can get your calculator out and go 2 times 768 plus 2 times, what did I say, 1152 plus 2 times, last one is 384. So 4,608 square inches. So then we have to finish the question. Okay, it says, will 1 can of stain be enough for 2 coats? So if you need 2 coats, you're going to cover twice 4,608. So 2 times 4,608. So that's still in your calculator. Just press times 2. Doesn't matter what kind of calculator. That will do it. 9,216. Okay, so 1 can covers, let's just see, what did it say? It covers 80 square feet. So we need to figure out what 80 square feet is in square inches. Okay, so let's take a look at, yeah, so in the back of your book, your workbook, it has, so we're doing imperial, and it says 1 square foot is 144 square inches. So because it's an area conversion. So because basically 1 foot is 12 inches, 1 foot times 1 foot is 1 square foot. 12 times 12 is 144. So 144 square inches in 1 square foot. So multiply those together. 80 times 144. That means 11,520 square inches is how many square inches the paint covers, 1 can. And so we have to then compare that to 9,260. So 9,216 is less than 11,520. So 1 can is good. Okay. And that's that question. Okay. Remember, you can always pause or go faster because this is in YouTube, so there's the ability to slow it down or go faster. The North End Water Pollution Control Center in Winnipeg has cylindrical tanks. Bacteria in the tanks clean wastewater. Each tank has a radius of 16.5 meters and is 8.6 meters high. Maintenance staff paint the tops and sides of the tanks. What surface area needs to be painted for each tank to the nearest square meter? So basically, they've done, this is a net. You may think, oh, is that the cylinder there or whatever? This is actually the net. So really, it's a big cylinder, straight down, big circle. And so that's what it looks like. Right? And so this long rectangle is that outside part to it. So it's one rectangle and two circles, right? So they want to paint the tops and sides of the tanks. What surface area each tank to the nearest? So the net represents a tank. Label the measurements of the width of the rectangle and the radius of each circle. So the radius is, remember, 16.5. And the height of the cylinder, 8.6. And they're in the same units. What is the circumference of the top of the cylinder? So basically, because the circumference of that circle is this length here. So remember, it's pi times 2 times the radius, or 2 pi r. Okay, now let's get our calculator out. We'll probably get the decimal form here because we're going to use it. So if we use the order that they have, we'll have pi times 2 times 16.5. But let's keep some decimal places because we're not done. So 103.672, let's go to 4 decimal places. 103.6726. 103.6726. Okay. What part of the rectangle has the same measurement as the circumference of the circle? The length. Okay. What are these areas? So the area of the rectangle is 8.6 times the length, which we calculated here. So in our calculator, we still have that value. Just press times 8.6. 891.58, let's go 584. 891.584. 891. Oh, sorry. What did I just say? I got distracted. 584. Okay, this should be really equal, so that's what distracted me. The circle is pi times 16.5 squared. Okay, so pi times 16.5 squared. Oh, I'm going to go back and insert one. There we go. 855.2986. 855.2986. 855.2986. Okay, what is the surface area to be painted? So, so notice how it says top and side, because we have to be careful here. So it says each tank has a radius. The maintenance staff paints the tops and sides of the tanks, not the bottom. What surface area needs to be painted for each tank? So we need the top of the cylinder, 100 and, no, sorry, top, we need the area of this is the circle, so that's 855.2986 plus the rectangle, 891.584. So you can add those in your calculator. I already have 855 on there, so I can just press plus. On my calculator, I can go up and copy, but if not, you enter what you've recorded. So 1746.9, 1746.9. Now we can round to the nearest one decimal place. Oh, and then this says to near square meter, so that would be, the 9 makes that go to a 7. Okay, so that's the end of that unit. Really, it's just using a net to calculate the surface area, and then maybe do some other work with it, like how many cans of paint, if you needed to paint it twice, all that kind of stuff. Okay, so now do the practice for 3.1 before you go on.